Determine all intervals of increasing trend or decreasing trend and determine the coordinates of all maxima, minima, plateaus, or cliffs for the function f of x equals x squared minus 4 divided by 2x minus 5. The first thing to do is find the domain. F of x equals x squared minus 4, a polynomial, the domain is all reals, over 2x minus 5, a polynomial, the domain is all reals, other than the fact that we have a denominator here and the domain requires that the denominator cannot equal 0. So 2x minus 5 does not equal 0. We can solve for x by adding 5 to the other side and dividing by 2. So x cannot equal 5 halves. The domain will be all real numbers except for 5 halves. That means it'll be all real numbers to the left of 5 halves. It starts at negative infinity up to 5 halves. It will not include 5 halves, round bracket. And then all numbers to the right of 5 halves, it will start again at 5 halves, not including round bracket up to positive infinity. The domain is all real numbers except 5 halves. The next thing to do is find all critical numbers. We will take the first derivative. F of x is a quotient of two expressions here, so the first derivative will make use of the quotient rule. The derivative of the numerator, 2x, times the denominator left alone, 2x minus 5, minus the numerator left alone, x squared minus 4, times the derivative of the denominator, 2, and the entire thing over the denominator squared. We can distribute the 2x in here, which will give 4x squared minus 10x. We can distribute the negative and the 2 in here, which would give a negative 2x squared and a positive 8. We'll leave the denominator alone. We can combine like terms together in the numerator. 4x squared minus 2x squared is 2x squared. We have a minus 10x and a plus 8. It's a trinomial quadratic, written in descending order, over the denominator. We want to fully factor the first derivative. In the numerator, there's a common factor of 2. That will leave behind an x squared minus 5x plus 4. In the denominator, it's technically already factored because it's a quantity squared. In the numerator, we can further factor the trinomial quadratic into an x and x. We need two numbers that multiply to be a positive 4 and add to be a negative 5. It sounds like a negative 4 and a negative 1 will take care of this over the denominator, which is 2x minus 5, and then squared, just meaning there's two factors of 2x minus 5. So that is fully factored. So we have a first derivative that is a single fraction. All powers are positive, and it is fully factored. So we can now set the numerator equal to 0 and the denominator equal to 0 and solve for all x's. Starting with the numerator, the 2 can divide over, and it'll still be 0. Since it's already factored, we can see that x equals 4 and x equals 1 from the factors. Now the denominator, 2x minus 5 squared equals 0. We can start by taking the square root of both sides. The square root of a square cancel each other out, and it'll be 2x minus 5. Square root of 0 is a 0. We can add 5 to both sides, 2x equals 5, and divide both sides by 2. X equals 5 halves. We now check to see which of these are in the domain. The domain is all real numbers except for 5 halves. The x equals 4 and x equals 1 are real numbers, but they are not equal to 5 halves. We do keep those. They are critical numbers. The x equals 5 halves is not in the domain, so we cross this one out, and we have two critical numbers. We can now draw a domain line, a line representing the domain. It has no left end because it begins at negative infinity. It has no right end because it goes to positive infinity. But it does have a 5/2 not included. And that 5/2 is not included because it's making the denominator be a 0. And that means that that 5/2 is a vertical asymptote. So right at 5/2, which is not included on the domain, we indicate it's a vertical asymptote with a dashed line. So that's to make sure we don't think of it as being a critical number. The domain is already split into two intervals. Now we can put our critical numbers on here in order. 5/2 is 2.5, so x equals 1 will be to the left of that, and x equals 4 will be to the right of that, and that further breaks the domain up into 4 intervals. We can pick a test value in each of these intervals. The first interval is negative infinity to 1. 0 is in that interval. The next interval is 1 to 5/2. 5/2 is 2.5, so 2 is actually in that interval. And then 5/2 to 4, 3 is in that interval, and then 4 to positive infinity, 10 is in that interval. We can test the trend by plugging the test value from each interval into the first derivative. We don't care about the value of the first derivative, just whether it is positive or negative. So the best version to plug it into is the fully factored version. A couple of things about this. It's right here. The 2 up here is positive, and then the 2x minus 5 is quantity squared. And that will always be a positive number because of that square. And therefore, only the x minus 4 and the x minus 1 will matter. Those can be positive or negative, so we will have to keep both of those. So here's the only portion of the derivative that matters. Plugging a 0 in there, we have 0 minus 4, which is negative, 0 minus 1, which is negative. Negative times negative is positive. We have a positive first derivative, which corresponds to an increasing trend. Plugging the test value of 2 in the portion of the first derivative that matters. 2 minus 4 is negative. 2 minus 1 is positive. Negative times positive is negative, which corresponds to a decreasing trend. Plugging 3 in to the portion of the derivative that matters. 3 minus 4 is negative. 3 minus 1 is positive. Negative times positive is negative, which corresponds to a decreasing trend. And then plugging 10 into the portion of the first derivative that matters. 10 minus 4 is positive. 10 minus 1 is positive. Positive times positive is positive, which corresponds to an increasing trend. So we have an increasing trend from negative infinity to 1, and then union, because it's happening again, from 4 to positive infinity. We have a decreasing trend happening from 1 to 5/2, and union, because it's happening again, from 5/2 to 4. We cannot put those intervals together because that 5/2 is not included on either of them. Round bracket on it. It's a vertical asymptote here. Right at the critical number of x equals 1, we have a trend change from increasing to decreasing, and that means x equals 1 will be a relative maximum. So it has an x-coordinate of 1. It has a corresponding y-coordinate that can be found by plugging the 1 into the original function. So y will be f of 1, which will be 1 squared minus 4 divided by 2 times 1 minus 5. 1 squared is 1 minus 4. 2 times 1 is 2 minus 5. 1 minus 4 is a negative 3. 2 minus 5 is also a negative 3. Negative over negative is positive. The 3's cancel. It leaves a positive 1. So we have a relative maximum at 1, 1. Right at the critical number of x equals 4, we have a trend change from decreasing to increasing. That means 4 is a relative minimum. Has an x-coordinate of 4 and a y-coordinate that can be found by plugging the 4 into the original function. So y equals f of 4, which is 4 squared minus 4 divided by 2 times 4 minus 5. 4 squared is 16 minus 4 over 2 times 4, which is 8 minus 5. 16 minus 4 is a 12. 8 minus 5 is a 3. And 12 divided by 3 is a 4. So at 4, 4, there will be a relative minimum. The x value of 5/2 is not a critical number. It's a vertical asymptote. This shows the trend around it, but it is actually a vertical asymptote for the graph. So we have 2 intervals of increase, 2 intervals of decrease. We have a relative max at 1, 1, and a relative min at 4, 4.